Hello students, welcome to Akshara IT Foundation. See, today we are going to start the new chapter, that is fluid mechanics. Okay, fluid mechanics. So we'll see there what is a fluid first. Chapter name is fluid mechanics. Fluid mechanics. So fluid mechanics is nothing but the branch of physics which deals with the fluid which are at rest and motion. So both about the fluids, the chapter will be discussed and give the details about all the fluids there. Okay, so we have the fluids are two types. So they are examples of the fluids. They are liquids and gases. Liquids and gases. Liquids and gases. Okay, so first of all, what is a fluid there? Okay, so fluid is nothing but the substance which can flow. The substance which can flow. The substance which can flow is called fluid. So there are two types of fluids. There are liquids and gases. Liquids and gases are known as fluids there. Now this fluid mechanics, it will be gives the details about the fluid and the nature of the fluids and what are the properties of the fluids we are going to discuss in this chapter. So here the fluid, basically it is about the liquid and gases. So we know that the solids have the particular shape and size, but whereas here the liquids and gases, they doesn't have the particular shape and size because of the intermolecular forces. So in the solid there are the strongest intermolecular forces will be there, then all the molecule will be closely packed and that forces are greater in the solids. But coming to here liquids and gases, so in the liquids the intermolecular forces a little bit greater than the gases, so there are the molecules will be certain distance there. So compared to gases, so what happens there, compared to the solids, the liquids will have the expansion distance between the molecules is greater distance there, means intermolecular distance are greater. So due to that reason the liquids does not have the particular shape and size, but so because of this the intermolecular forces, intermolecular distance between the molecules, there is they occupy, so they occupy the shape of the container. So coming to gases, they even does not occupy the shape of the container there. Suppose if in a container, if a gases is taken there, then whole atmosphere also, so it occupies there. So that is due to there is the intermolecular forces, weak intermolecular forces will be there and larger the intermolecular distance. So that is the reason why here, so liquids and gases, they does not have the particular shape, but the liquids will have the shape of the container and the gases does not have the shape of the container also. That is the reason why here, suppose if it is a solid there, so solid, if an object is there in the solids there, so then if you apply the one single force at any point on the solid there, the motion of the body will be takes place there. Okay, we have discussed there in the kinematics, if the force is applied, the body will be coming into the motion. So but here, if you apply the force on the liquids, it does not move, the whole liquid cannot be moved there. The point where it is applied there only the molecules will be moved there. Okay, so it is difficult to place the motion of the whole liquids and gases there. So that is the reason why here, instead of using this force, physical quantity, to study these liquids and gases, we will be use the pressure. Okay, so now we will discuss about the pressure there. What is the pressure here? Pressure. So pressure is nothing but force acting on a body per unit time. Per unit area is called the pressure. So force acting on a body per unit surface area. Surface area is called pressure. There. Okay. So now the pressure, formula of the pressure is denoted by the letter capital P, and the formula can be written as here, pressure P is equals to, so force by area, force by area. So force is denoted by the letter here F, and area will be denoted by here A. This is a formula of the pressure. So this pressure is a scalar quantity because it is force divided by the scalar. So we'll get a scalar quantity. So here the SI unit of this pressure. So SI unit of pressure. SI unit of pressure is, so force is measured in newtons and area will be in meter square. So it will become Newton per meter square. This Newton per meter square is also known as a Pascal. Pascal is a scientist. To honor the scientist Pascal, the Newton per meter square is given as a Pascal. Okay, then see here CGS unit. CGS unit of force. CGS unit of pressure. CGS unit of pressure is, so it is a dyne per centimeter square. Dyne per centimeter square. Dyne per centimeter square. That is a CGS unit of the pressure there. So now if the pressure is applied on the object there, so how can you apply the pressure there? Suppose here the liquid is there in this container, or a gas, let us consider there. So here over the surface of this fluid, we will apply the pressure by using the piston. So piston, it has the, so one handle base here, handle will be there, and area of cross section, area of plate will be there. So this whole area place, suppose here the force is applied on this handle of the piston, then so that force will be act over this bottom of this whole area of the piston. So then that will be apply the pressure on the liquid there. Suppose here the fluid, if it is a liquid or if it is a gases, then so this force which is applied here on particular surface area, so then it will be act there as a pressure on the liquid there, so that the whole liquid can we can say it is a liquid or a fluid there. So whole it will be the motion of the liquid or fluid can be takes place there. So then to move the liquid, so to move the fluid, then the physical quantity which we will use here, the pressure there. Okay, so the pressure is it is the scalar quantity. So it is a scalar quantity, and the dimensional formula also we can write here. Dimensional formula of pressure. Dimensional formula of pressure is, so from the SI unit we can write the dimensional formula. So here Newton. So Newton dimensional formula is m power 1, L power 1, T power minus 2 we can write here, divided by L power 2. So now if we write here, so m power 1, if you bring here L square to the numerator, so it will become L power minus 1 and T power minus 2. This is the SI unit of the dimensional formula of the pressure there, dimensional formula of pressure. Okay. So then one more physical quantity. To study this fluids will require one more physical quantity, that is the density. So now we are going to discuss about the density also. Okay, density. So density is denoted by the letter D or small d or capital E. So what is the density here? Density of an object there. So density is nothing but mass per unit volume of an object. Mass per unit volume of an object. So mass per unit volume of an object. Volume of an object is known as density. So the density formula of the density is denoted by density D is equals to, we can use here capital D is equals to mass is denoted by capital M, and here the volume will be denoted by here capital V. Okay. So now the SI unit of this density, SI unit of density, SI unit of density is kg per meter cube, kg per meter cube. So here the mass will be measured in kgs and here the volume will be measured in meter cube. So now the CGS unit. So CGS unit of density, CGS unit of density is gram per centimeter cube, gram per centimeter cube. Okay. And the density also, it is also scalar quantity, it is also scalar quantity, scalar quantity, scalar quantity. So density is a scalar quantity. And the dimensional formula. So dimensional formula of density, dimensional formula of density, dimensional formula of density is, so how can you write from here? SI unit, from the SI unit. So mass can be denoted by here m and by here L cube, L cube, and there is a only two are there, so we can write here, so m power 1 L power minus 3, that is the dimensional formula. So it is also written as here m power 1 and L power minus 3 T power 0. You can write like this also. That is the dimensional formula of the density, dimensional formula of density. By using these two physical quantities, we are going to study the fluids. That fluids are known as the gases and the liquids. About the gases and liquids, we are going to study here. Okay. So fluid mechanics is nothing but the branch of physics which studies about the fluids which are at rest and motion there. Okay. So this fluid is classified in two types. So that is here we can say fluid statics and fluid dynamics there. Okay. The fluid statics is nothing but the branch of physics which deals with the fluids which are at rest. That is called the fluid statics. And fluid dynamics is nothing but the branch of physics which deals with the fluids which are in motion. Okay, that is called the fluid. These are the two classification in the fluid mechanics there. Okay. So to study the fluids, here we require the physical quantities, this density and the pressure. By using the density and the pressure, we are going to discuss. So now here we see there one more physical quantity here after the density, that is the relative density we will see here. So next one is next physical quantity, relative density. Relative density. Relative density. So relative density is nothing but relative, the term, it will be gives the relation between. So comparison between. So one density, one of the density of the object to the other density. So we can write here the density, relative density is nothing but the ratio of density of substance to the density of the water at 4 degrees Celsius is called the relative density. Okay. It is the ratio of, it is defined as the ratio of it is defined as the ratio of density of substance to the density of water at 4 degree Celsius. At 4 degree Celsius. That means what, the density of substance will be compared with the, so for the density of water at 4 degree Celsius, then how much the density of the substance it will be there. So that quantity will be given, it will be give the relative density of that substance there. Okay, it will be compared there. 4 degree Celsius is called relative density. So relative density. Okay. So now here relative density formula can be, relative density is denoted by RD, capital RD, that is equals to, so density of substance, density of substance, density of substance to the density of water, density of water at 4 degrees Celsius, at 4 degrees Celsius. Okay. So here we are going to write the relation between SI unit, the relation between SI unit of density and the CGS unit of density. Okay, SI unit of density and the CGS unit of density. Okay, so how to find out the relation? So next to write down there the relation between, and this one more thing here we need to remember that the relative density is a dimensionless physical quantity, unitless and dimensionless physical quantity, because it is a comparison of the two density of the two different substances. So then the SI units will be cancelled. So there is no dimension, there is no unit dimensions and dimension formula, units and dimension formula there. Okay. So relative density is a dimensionless and unitless physical quantity. So now the relation between the SI unit of density, SI unit of density, SI unit of density and CGS unit of density, CGS unit of density, CGS unit of density, SI unit of density and CGS unit of density. So SI unit of density, we know that is SI unit of density is kg per meter cube, kg per meter cube. To convert this into CGS units, so we can write here 1 kg. 1 kg is nothing but how many grams there? 1000 grams. We can write there 1000 grams, and here meter cube, 1 meter 100 centimeter. So we can write here 100 centimeter. In place of 1 meter, we can write here 100 centimeter cube. Okay. So now this can be written as here 10 to the power of 3 grams, and divided by here 10 to the power of 6 will come now. 100 whole cube. 100 whole cube is nothing but 10 to the power of 6 will come here. 10 to the power of 6 divided by centimeter cube. Divided by centimeter cube. Now you send this 10 to the power of 3 into 10 to the power of 6, you send to the numerator, it will become 10 to the power of minus 6. So gram per centimeter cube there. Gram per centimeter cube. So here we can write that is a 10 to the power of minus 3 gram per centimeter cube. So now the relation will get here. The relation between here the CGS unit of density and the SI unit of the density is here 1 kg per meter cube is equals to 10 to the power of minus 3 gram per centimeter cube. So we'll write that here. So 1 kg per meter cube is equals to what we got here, 10 to the power of minus 3 gram per centimeter cube. So from this again we can write here 1 gram per centimeter cube. So if you want there 1 gram per centimeter cube, this term we should send here, there it will become there 1 by 10 to the power of minus 3 kg per meter cube. So this also it can be written as here 10 to the power of 3 kg per meter cube. We can write this also written as here 1000 kg per meter cube, 1000 kg per meter cube. Okay, therefore here we'll get there. So 1 gram per centimeter cube, 1 gram per centimeter cube is equals to 1000 kg per meter cube, 1000 kg per meter cube. So 1 kg per meter cube, this one and this one and this one we should remember. So in this while solving the numericals, we'll use this relation. Okay. So that is about the relation between CGS unit of density and SI unit of density. Okay. So suppose if there are two liquids, okay, are taken, and see if any liquid, if you take there, it will be have certain density, and because if you take the mass and certain space volume, it will be occupied there. Okay. So then there is a mass per unit volume will be present there, so that every substance it has a certain density there. Okay. So then like two liquids, let us consider the water and the milk. then water will have certain density and the milk has certain density there. If they are combined together, then so now it will become a water and milk solution, it will become there. So that solution will have the different density then. It is not like it is not equal to the density of water, it is not equal to the density of milk there. So there is the density of mixture will be there. So now we can write here density of the. Now we are going to discuss if in that way if two liquids are mixed and become a solution, then what is the density of that mixture of the two different density of the fluids, okay, or liquids, okay, that we are going to see now. So that is the density of mixture, density of mixtures, density of mixtures, density of mixtures. So in that we'll take here two substances having the densities rho 1 and rho 2, rho 1 and rho 2, and here total density of a mixture there. So it means suppose if you take one like water, if you take there, so that two densities, two substances having the density rho 1 and rho 2, and they have the rho 1 can be written as here mass per unit volume there. So that substance, first substance will have the mass and volume, and second substance also it has mass and volume there. So now the density of mixture, so the density of mixture it can be written as here. So density of mixture, we can write here mass of the first substance plus this total mass of the two substances divided by how much they will occupy the volume there. So V1 plus V2 we can write there, V1 plus V2, okay. This is a basic formula we'll take here, density of the mixtures. If the two mixtures will have, the two substances having the mass and volume, they are mixed together, then the density of mixture will get here. Now here we'll take here suppose two density of the substances rho 1 and rho 2, so they have the equal mass. So if they have the equal mass, then what is the density of mixture equation we'll get here. And next we are going to see here if they have the equal volume there and different masses, then what is the equation we are going to get for the density of the mixtures we are going to see here now, okay. So now first case we consider in this density of mixtures, if the two substances having the different masses and the same volume, okay. We'll see here how the density of mixture it is takes place there, okay. So what is the formula we are getting, we are going to get, that we are going to see now. So now if two substances having M1 and M2 masses, and equal volume and equal volumes, that means V1 is equals to V2, that is equals to V we can write here now, okay, volumes. Then the density of mixture, then the density of mixtures, is given by this one, okay. So density of mixture formula, what do we get there? Here rho mixture is equals to here M1 plus M2 divided by V1 plus V2 we can write here now, okay. So there are the two substances having the masses M1 and M2 we can write. So here M1 by M2 is equals to here, what can write there, V1 plus V2 is equals to V only we can write then, V. So now here how to write there V1. So M1 what can write there, mix rho 1, first substance will have the density rho 1 and it has a mass M1 and its volume is V. V1 is nothing but V there here. In the same way second substance having the density rho 2, that means it is the ratio of so M2 mass of the substance and the density there. So from this we can write here what there. So M1 is equals to rho 1 into V and here M2 is equals to rho 2 into V we can write. Now these two if you substitute in this mixture formula, density of the mixture formula, density of mixture is equals to M1 M2, what you got there, rho 1 plus rho 2 V we got, divided by here we can add there, that is a V1 plus V. So here V1 plus V means V plus V we can write now. That is V1 is equals to V2. So V1 is equals to V we got there. So here V1 is equal to V will write there here, and V2 is equals to also V will write there. So it will become there 2 into V it will become. Then here the numerator and the denominator common term is what there V, that can be cancelled there. So by using this now here we'll get there. So density of the mixture here we'll get there what there. So rho 1 plus rho 2 divided by 2 into here this V. So V and V will be cancelled here. So if it is cancelled there, therefore the density of the mixture will get there rho 1 plus rho 2 by 2. So that means there the formula of the density of the mixtures, if they having the different mass and the same volumes, will get here density of the mixture formula is this one. So it is the first case, and now we are going to see here next second case. In the second case, the two substances will have the equal mass and different volumes. Then what it is, the density of the mixture expression is what? That we are going to see now. Okay. So now next one is density of the mixture. Second case, density of mixtures when they have equal masses and different volumes. Equal masses, that means here m1 is equals to m2 is equals to m, and different volumes are mixed. Then the density of mixture. Then the density of mixture is given by this formula. So that how can write here density of the mixture rho mixture is equals to, we can write here m1 plus m2. This is a basic formula, v1 plus v2 here. So what did I said there here? So density of the mixture here we can write here. So m1 is equals to m2 means m1 is equal to m2 is equals to m. It is then here we'll write there. So m1 is equal to m plus m2 is equals to m, we can write here, divided by v1. So v1 plus v2. We should write here v1 and v2 there. How can I write from this here? So rho 1, the first substance will have the density rho 1. Then here the mass is m and density is here v1 there. So from this what can we write? V1 is equals to, so m by rho 1 we can write here. In the same manner, rho 2 is equals to m divided by v2 we can write here. So from this v2 is equals to m by rho 2 we can write now. These two values will substitute here in this equation. So we'll get the, and substitute there, and we should simplify. We'll get the equation of the density of the mixtures when they have the equal masses and different volumes are mixed together. So this will become here in the numerator, it will become 2m divided by v1 is what there? So v1 is nothing but, here this is the, yes, correct one. So v1 what you got here, this one? v1 is m by rho 1. So here m by rho 1 plus v2 what we got here, m by rho 2. So in the numerator and the denominator, the common term is mass. So if you take common here, it will be remain there. So m divided by m into, here we can write there 1 by rho 1 plus 1 by rho 2 we can write here. This m and m will be cancelled. If you simplify here, what do you get there? So rho 1, rho 2 will be the LCM. Then here rho 2 plus rho 1 will become. So as a whole we'll get here 2 into this rho 1, rho 2 will go to the numerator. 2 into rho 1, rho 2 divided by rho 1 plus rho 2 will get there. So this is 2 into rho 1, rho 2 divided by rho 1 plus rho 2 will get. Okay. So therefore the density of the mixture, expression of density of mixture, if they have the equal mass and the different volumes are mixed, then we'll get here the expression is rho into 2 into rho 1, rho 2 divided by rho 1 plus rho 2. Rho 1 plus rho 2 will get here. Rho 1 plus rho 2. So that is the expression of density of the mixtures. So now we are going to see here what are the factors that are going to be. Okay, so now next one we'll see there. What are the factors that are going to be affect the density there? So factors affecting the density. So what are the factors that are going to be change the density of the substance we are going to see here. So first factor, that is the temperature. If the temperature of the liquid or the fluid is increases, then the so this density will be increases there, because the volume will be increases, volume changes there, so that the density of the body also it will be changed there. Okay. So then the next one here, next factor, that is about the that is a thrust. Okay. Then pressure. So these are all the factors which are going to be affect the density of the substance there. Okay. So now we'll see here. So how this density will be get affected due to the variation of the temperature of the body we are going to see now. Okay. So we know that from the Boyle's law, we have the Boyle's law now. From the Boyle's law, what can we write there? So at the constant temperature, pressure of given volume of gas will be inversely proportional to the volume of the gas. Now we can write there. So P is inversely proportional to V at temperature is constant, constant temperature. Okay. So now if the temperature increases, what happens there? Volume also increases, then density of the liquid. So volume increases, density will be decreases now. So now by using that we are going to get the relation here. Okay. So now we'll see there factors affecting the factors that are affecting the density. Affecting the density. See, according to Boyle's law, at a constant temperature, the pressure of given gas is inversely proportional to its volume. So P is inversely proportional to volume at a constant pressure, at T constant. Okay. So now from this we can write here PV. So if you remove this proportionality, we can write here. So constant, equivalent constant we can add there here, so that this equation also can be written as here. So P1 V1 is equals to P2 V2, we can add there here. P1 V1 is equals to P2 V2. Okay. So from this, okay. So now here we know that here suppose the temperature increases, temperature of the substance, suppose in the piston, in certain cylinder, there is a gas has taken and here one piston is there here. Okay. So then what happens here? The gas will be present in this. So gas is a fluid, no? So gas will be present in this cylinder there. If the temperature is provided, heat provided there, the gas temperature of the gas increases. If the temperature of the gas increases, what happens there? So here the pressure will be applied by the gas on the piston will be moved there, means volume increases there. If the volume increases, then what happens there? So from the density formula is what there? Mass per unit volume there. If this is increases, density of the substance will be decreases there. So volume increases means temperature increases, volume increases. If volume increases, density will be decreases. So in that way, the density of the substance. So the temperature increases, we have seen there the density of the substance will be decreases. So how it is? If the temperature of the gas increases there, the volume of the body will be increases. If the volume of the body substance is increases, then the density of the substance will be decreases there. Okay, that is the one factor. It will affect the density of the substance. And next one is the pressure. So what happens the pressure? So pressure acting on the gas. So how the pressure can be act there? So we have to apply the force on the piston. If you apply the force on the piston, then that piston will be apply the pressure on the fluid there. So the fluid, volume of the fluid will be decreases. If the volume of the fluid will be decreases there, then what happens here? If this is the volume will be decreases, then the density of the substance it is increases. Then now here pressure increases. So pressure increases, then the volume of the substance will be decreases. If the volume of the substance decreases, then the density of the body, density of that substance increases there. Okay. So these two physical quantities will be affect the density of the substance. Okay. These two physical quantities will affect the density of the substance. And next one here, thrust. Here we have seen there this force what we are applying on the piston, that is called the thrust. Thrust is nothing but simply we can say force which is applied by the man or machinery on the piston. So which is used to apply the pressure on the fluid. Okay, that is called the thrust. So thrust or force. So we know that the thrust, SI unit of thrust is Newton. That is nothing but kg meter per second square, and it is a force. So it is a vector quantity. Okay, then here CGS unit is dynes. We can say here the relation between the Newton and the dyne. So that is 1 Newton is equals to 10 to the power of 5 dynes there. Okay. Dimension formula of the Newton. So m power 1, L power 1, T power minus 2 will get there. Mass into acceleration. So mass is what there kg. Acceleration dimension formula is L power 1, T power minus 2. Okay, that is about the thrust. Okay, now now we are going to discuss about the, already we have learned what is the pressure here. In the introduction we have seen there the pressure of liquid. Pressure is nothing but force acting per unit area on the substance. Okay. So now here the SI unit of the pressure we have seen there, that is a Pascal, or we can say it is a Newton per meter square. The Newton per meter square is given Pascal. It is nothing but the Pascal there. So then what are the relations this? So what is a Pascal we can say here? Okay, when 1 Newton of force is act 1 Newton of force is act on the 1 meter square area of the substance. Okay, then the pressure acting on the body, pressure acting on the substance, it is said to be the 1 Pascal. 1 Pascal. Okay, so now the relation between Pascal, Newton per meter square. Newton per meter square we can say here pressure is there, no? So pressure formula already we have know that. So F by A we can write here, F by A. F is nothing but Newton. So Newton per meter square. So now here this Newton per meter square is nothing but we can say here Pascal there. Okay. Then we can write here this 1 kg of force. So even we can write here. So in terms of kgf per meter square also we can add there. So kgf per meter square, Newton. So Newton is a SI unit of the force there. Suppose here 1 kg of mass of the substance. Okay, applying the force on the substance of a unit area, then so that force can be written as here 1 kgf. So 1 kgf by meter square is equals to how many pascals? It can be written as here 10 pascals, or we can say here 9.8 pascals. 9.8 pascals. So Pascal, the symbol of the Pascal is P suffix A we can add there. PA, P and small a we can add there. Capital P and small a. That is the symbol of Pascal, the SI unit of the force. So we can add here Pascal will be the SI unit. Pascal will be the SI unit. All our small letter we can add there. Okay. So Pascals we can add there. That is the about the pressure. And we are going to discuss, there are the different types of pressures are there. The types of pressures will be learned in the next class. So there are atmospheric pressure is there, absolute pressure is there, gauge pressure is there, that we are going to discuss in the next class. Okay. Thank you children. Have a nice day.